You know, uh, have you ever stared helplessly at a screen just completely full of red squiggly lines in your IDE?
Oh, yeah. Way too many times.
Right. You just wrote this brilliant dynamic metaprogramming masterpiece in Python. It runs flawlessly.
But the static type checker is just screaming at you.
Screaming like you've completely broken the internet.
That is the classic Python paradox, really. The language lets you build these incredibly powerful dynamic things on the fly, but the type system often gets left in the dust.
Exactly. And that's why today we are diving into a really exciting stack of sources. We've got a Vercel engineering blog post, the official documentation for PTP 827, and a very lively Python discourse thread.
It's a great stack.
Our mission today is to explore how PPP 827, which is all about type manipulation, proposes a programmable typing core. It is honestly going to make coding in Python feel like absolute magic for you.
A structural shift like this is just a fascinating leap forward for the language.
Okay, so let's unpack this. Python's runtime is famously dynamic, right? It allows us to generate classes or whole APIs with just a few lines of code.
Yeah, but the disconnect happens because static typing struggles to keep up with that. Well, unless developers want to write massive amounts of tedious boilerplate.
Or rely on those fragmented custom type checker plugins.
Exactly. So PP 827 introduces a radical solution, giving Python a programmable typing core. Conceptually, it lets developers manipulate types using other types.
So instead of manually redefining every single variation of a data structure,
You use built-in type operations to transform an existing type into a new one.
I love that. It takes the best concepts from TypeScript's utility types, like pick and omit, but custom crafts them for Python's unique ecosystem.
Right. You essentially write a formula for your type, and the type checker calculates the result,
And calculating that mechanically means completely eliminating massive amounts of boilerplate code.
which is huge. When you can automate that much repetitive typing, developers can actually focus on logic, system design, and building the future.
Speaking of automating the repetitive stuff to unlock bigger impact, that actually aligns perfectly with our sponsor. This podcast is sponsored by Embersilk.
Oh, nice.
Yeah. Need help with AI training or automation or integration or software development? Uncovering where agents could make the most impact for your business or personal life. Check out embersilk.com for AI needs.
Getting back to that automation that PP 827 brings, what's really fascinating here is the practical application for you. Look at the FastAPI framework.
Or the Prisma-style ORMs.
Exactly. Right now, to build CRU'd applications, you often end up defining multiple, slightly different data models.
Oh, it's exhausting.
Yeah.
You've got your base hero model, your hero create model, your hero update model.
And maintaining them all is a nightmare. But PP 827 lets you tell the type system, hey, take my base database model, but mechanically strip out the primary key for the create model.
Or make all the fields optional for the update model.
Yes, you write the logic once, and the type checker handles the derivatives seamlessly.
Looking at the Python discourse thread, though, this shift is definitely sparking some debate.
Yeah, some developers are naturally worried about adding too much complexity.
Pointing at TypeScript and fearing Python might get bogged down by syntax soup.
But the framework creators are absolutely thrilled. Sebastian Ramirez, the creator of FastAPI, explicitly pointed out how many new features this unlocks for users.
And the technical execution is what really makes this an engineering marvel. Unlike TypeScript, which gets completely erased before running.
Python annotations must work at runtime.
Right. Frameworks like Pydantic and FastAPI use those annotations to validate data while the program is actually executing.
And the Vercel engineering team behind this PP designed these type manipulations to stay introspectable at runtime.
So it's a living part of the code, not just a static check.
Exactly. This means as AI agents take on a larger share of writing code alongside us, having thorough, expressive type checkers ensures you, and the AI helping you, can safely ship cleaner, more succinct software.
It is incredibly optimistic.
It really is. It raises an important question to leave you with today. As type systems become this expressive and programmable, could we soon see a future where our code structures become entirely self-documenting and self-verifying?
Freeing human creativity from syntax completely. What a great thought to mull over. If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.